All right, fifth graders, welcome to the end of Module 3 test. Let's take a look at question number 1. It says, on Sunday, Sheldon bought 4.5 kilograms of plant food. He used 1 2/3 kilograms on his strawberry plants, and he used 1/4 kilogram for his tomato plants. The question that we need to answer is, how many kilograms did plant food did Sheldon have left? We have to write one or more equations to show how he reached his answer. So we need to think about how much did he start with. If we think about how much he started with, well, he bought this much plant food. So that is the amount that we started with. Okay, so how much did he use? Well, he used this and he used this. So stop and think about, when he uses it, does he have it or not have it anymore? What kind of math will that be? Okay, and then we notice, well, maybe you don't notice because I've kind of covered it up, the fractions here all have different denominators. They have different units. We have a 2/2, we have a third, a 3, and we have a fourth, a 4. So if I'm going to combine or take away any of these fractions, I will need to come up with a common unit. If I'm not sure what to do about that, I could look for what is a multiple of 2, 3, and 4 in the multiplication chart, and then however I would multiply the bottom of that fraction to rename it, I would need to multiply the top too. So I'm not going to solve this problem for you, but I am going to solve a problem that is similar. So let's take a look here. Let's think Mrs. Z, oh, gotta move this way over here. Okay. Mrs. Z made 1 1/4 pounds of fudge. She ate, let's say, a 1/3 pound, and her kids ate an 1/8. Let's make it a 1/6 pound. How much is left? Okay, so again, here's my whole. This is how much I'm starting with. So I am going to start my sentence with 1 1/4 pound, because that's how much I'm starting with. Okay, it says I ate a 1/3 of a pound. Well, if I ate it, it's certainly not there anymore, is it? Okay, so I know in math that would make most sense for me to subtract that 1/3 pound. Okay, my kids also ate some. My kids ate a 1/6. Okay, so they are going to, I'm going to take away also a 1/6 of that. So what does that equal? Okay, well, again, in order to solve this, I'm going to have to rename these, because right now I've got a 1/4, and I've got a 1/3, and I've got a 6. And if I think about my multiples, I can go 4, 8, 12. Well, I can't turn the 1/3s or the 6 into 8ths, but I can turn them all into 12. So I'm going to rename these as 12ths. So I'm going to have 1 and so many 12ths. And I'm going to have to take away the number of 12ths I turn the 1/3s into, and then I'm going to have to take away the 6s that I turned into 12s. Okay, so what do I do to 6 turn into 12? Well, I double it. So if I double the bottom, I have to double the top. So that's 2 12ths. What would I do here? Well, I'd need 4 times as many pieces, and I need 4 times as many shaded pieces. So that becomes 4 12ths. What would I have to do here? Well, I'd have to multiply it by 3, and I'd have to multiply this one by 3. So this is 1 3/12 minus 4 12ths minus 2 12ths. Well, I can't take the 4 12ths away from the 3 because it's too big, but I can take the 2 12ths away. So if I take the 2 12ths away, I'd end up with 1 1/12. And I need to still take away the 4 12ths because I need to take away both parts. Well, that means I'm going to have to break this whole up into 12 of 12 pieces. So you can see right now I still have that 1/12 together over here. I've renamed this as 13 12ths. 1 1/12 is the same as 13 12ths, and I'm still taking away the 4 12ths, so my answer would be 9 12ths here. Good luck on solving your own problem.